Welcome to this explainer.
Okay, so today we're diving straight into a really fascinating and honestly incredibly frustrating debugging mystery in Haskell programming. We're looking at some real-world development notes from a dev named Ang, and these notes tackle one of the absolute sneakiest bugs you can ever encounter. We're talking about the hidden hazards of partial functions and how they can literally take a simple innocent error message and turn it into a catastrophic system failure. Now, I want you to imagine the ultimate programming nightmare for just a second. You've written a solid piece of software, you totally anticipated that things might go sideways, and you very carefully built this robust error handling system to gracefully catch those issues, right? Well, I have a question for you. What is actually worse than your program unexpectedly crashing? You guessed it, crashing while trying to report the crash. It's almost funny, but it brilliantly illustrates the painful irony of the situation we're exploring today. Honestly, there's just nothing quite as defeating as realizing that the very safety net you built, your own error handler, is the actual cause of a fatal runtime exception. Your program caught a minor hiccup, tried to let you know about it, and totally destroyed itself in the process. Section 1, the error handler crash, a glaring issue. So this brings us to a really specific scenario documented in Ang's notes. Let's walk through this failure cascade step by step, because it's kind of like watching a train crash. Step 1, the system encounters an invalid input. Nothing crazy, right? This happens all the time. Step 2, the error handler successfully activates, exactly as designed, ready to log the problem. But then, step 3, a function inside that handler called decode tries to process that invalid input and absolutely chokes on it, which immediately leads to step 4, a fatal runtime exception. The very system meant to catch the error just brought the whole program down. Boom. Section 2, partial functions. Understanding the root. Okay, to understand why that error handler choked so badly, we really need to look at partial functions. In Haskell, and actually functional programming in general, a partial function is defined as a function that is not defined for all possible inputs. I kind of like to think of partial functions as incredibly unreliable workers. You know, if you hand them exactly what they expect, they do their job perfectly. But the split second you hand them something unexpected, like an invalid input type, they have no idea what to do, so they just panic and shut down the whole factory. And that brings us to the specific culprit in Ang's code, which is l.decoding UTF-8. This was the exact function sitting right inside the error handler, tasked with decoding text so the error could actually be printed out for the user to read. Let's break down why decode UTF-8 is so incredibly dangerous in this specific context. See, because it's a partial function, it is not defined for all possible inputs. So when it encounters an invalid input type, which, let's be real, is highly likely inside an error handler, it doesn't just return a safe blank string. It doesn't give you a soft warning. No, it chokes. It throws an immediate, uncatchable runtime exception right there on the spot. Using a function with this kind of explosive behavior inside an error handler, that makes it highly, highly unsafe. Section 3, total functions, the guaranteed. So if partial functions are the problem, what's the answer? Well, as Ang points out in the notes, the total opposite of our unreliable partial function is a total function. A total function is guaranteed to return a result for all valid inputs without ever throwing an exception. These are your dependable, safe, clock in and do the work alternatives. They never panic. They never bring down the factory. And the absolute textbook example of this in Haskell is the show function. In the source notes, show is highlighted as the perfect, dependable way to handle this exact kind of data conversion safely. It's essentially the reliable hero we need when our system is under stress. So how does show manage to be so totally reliable? Well, it requires the data being passed to it to actually implement the show type class. As long as that one condition is met, it will smoothly convert that data into a string representation. It absolutely guarantees a result. You could literally pass it data in the middle of a catastrophic system meltdown, and it will calmly return a string, never once risking a runtime exception. But wait, what if you mess up? What if you pass show a type that doesn't actually implement the show type class? Well, this is exactly where Haskell's brilliant type safety really shines. Instead of waiting until the program is running to explode in your user's face, Haskell catches the mistake before the program even runs. You safely get a compile time error. It tells you exactly what you need to fix, right then and there, rather than giving you a catastrophic runtime crash later on. Section 4, Safer Haskell, choosing safety. Okay, we really need to put these two concepts head to head to understand what we should actually be writing in our own code bases. Contrasting these two is honestly like watching a totally rigged boxing match. In the red corner, we've got decode UTF-8. It's partial, it throws totally unpredictable exceptions, and it is fundamentally unsafe for error handling. And in the blue corner, we've got show. It's a total function, it's backed completely by compile time safety, and it is entirely safe to rely on when things go wrong. I mean, the winner for your error handling code is overwhelmingly clear. Ang summarizes this entire debugging saga with one perfect, hard-learned takeaway in the source notes. Quote, "Don't use a partial function inside your error handler. Doing so literally creates the exact scenario where your program crashes while just trying to display the error message. It completely defeats the entire purpose of having a handler in the first place." And, beyond just the sheer danger of crashes, forcing a partial function into your error handler just creates so much unnecessary busy work. Because the function is prone to failing, you end up having to write all this extra boilerplate code just to handle the inevitable conversion errors that the partial function is going to spit out. It's essentially coding with duct tape and prayers. It just makes your code messier, way harder to read, and vastly more fragile. So, as we wrap up this explainer today, I want to leave you with this thought to chew on. Take a good hard look at your own code bases, whether you're writing Haskell or something else entirely. Are you inadvertently inviting unreliable partial functions into your error handlers? Are the safety nets you've so carefully built actually laced with traps that could bring your entire application down? It is definitely worth an audit because the absolute last thing you want is a system that crashes just trying to tell you what went wrong. Thanks so much for joining me on this explainer, and I'll catch you on the next one.